right, so that's it. We are going to create the folder for today's class, which I'll call this class. Of course, it's class 13, so the folder of the class 13. Then we'll go into then the next thing we're going to do is to open this folder with a VS Code. So I'm switching my share to the VS Code. Okay. I believe you can answer my terminal, right?
Your VS Code, yes.
Yeah, my VS Code. Okay, so the very first thing I'm going to do is to we already have the project directory, okay, the class directory. So we are going to create the project directory just like we did in the last class, right? Just like we did in the last class. So today's code will be basically something very similar to last class code, because we use the same structure to just set up the project and start from there. So I'll make a directory and I'll call this directory. Let me just call it. Okay, so that's where our code base will be. All right. Then I'm going to make another, but I'm going to create the Docker Compose configuration. So use touch Docker Compose .yml. That's where Docker Compose configuration will be stored. Then I'm going to create a different Docker Compose, but this one will be for production. That's when we are done with when we are done developing the software and we want to push it to a remote server. We will not use this Docker Compose I've just created. Can you see my VS Code, or it's something else version?
I see your VS Code.
Okay. Right. So like I said, we need to create a different Docker Compose for production. So I'll call that Docker Compose .yml. Okay. Or sorry, this one is going to. All right, so we now have two Docker Compose. We have Docker Compose for the YML. This one will be for, like I said earlier, the production environment. We are not going to work on this now until when we are done with the main code, when we are done with the project. Then this will be the default Docker Compose or the default Docker Compose configuration. And we'll be using this for the development environment. Right? We'll basically be working with this for now until we are ready to deploy. Then the next thing we are going to do is to populate this compose file. And to do that, I am simply going to copy the compose file, the Docker compose file we made for the last class, that's class 12. So I'll simply copy and paste here. Then we'll go through it again. Okay. So that is that. Then we'll make some changes to this compose file. I don't want this service to be called projects. All right. You can see under services we have DB. That's our database, and this one is the name of our server or the name of our project. I don't want it to be called project. I want to rename it to the name of our project, which will be Twitter. Then we will also edit the build context. All right. Don't forget, in the last class, the base the project directory was called project, right? So that's why we had this /project under the build context, right? In this case, it is Twitter, not project. So like that, it is Twitter, not project. So we're going to change this to Twitter. This dot and slash means that this particular folder Twitter is within the current directory. Right? That's why we are accessing it with dot and slash. If it was in a different directory, okay, let's say if our project folder was, let's say, within this Twitter directory, maybe Twitter / something else, is having ./Twitter / something else. So with the current setup, this is one. Then the volumes, I want to mark Twitter, not project. So basically, wherever we have project here, we're going to switch to Twitter. Then we'll be running this command. We'll become server, up below focus this. Then we'll use an env file at the current directory, which is .env. I have not updated that yet. So this now we'll touch the env, and this is where we are going to store the environmental variables I'll be using in this project. Then that's that for env file. Then the port, we want to map this to the default port 8080. Then this particular service depends on the database service. That is, whenever we are starting this project, of course, we expect the database to be available. So that is why it depends on the database. Then our database is Postgres version 12 file time. Then it persists this data. Whatever data we store to the database persists to this folder. Then it depends on this particular env file, and it maps this port, and the database service is supposed to restart whenever there's a failure. Good. Then one more thing that we didn't use in the last class is Redis, and Redis is an in-memory database. What we mean by an in-memory database is, take for example, this normal Postgres database, right? It stores your data in your disks, like in your hard disks, okay? And Redis does not store data in your hard disk. It stores data in the memory, in the RAM. That's why it is called in memory. All right. But Redis persists data as well. All right. It primarily stores in the RAM, but it stores it back up in the hard disk as well in case of situations in which you restart your server. So I'm going to copy the code for the Redis here. Then when I'm done with that, we're going to go to the code and so we'll understand what it says. All right, so I've added another series to this project, this local compose project. All right, and it is Redis. If you can see at line 13, and it's making use of an image called Redis colon latest, meaning the latest version of Redis from Docker Hub is what we'll be using, and it exposes this port 6379. And this is a working directory. You can basically ignore all of this. You can ignore all of this. And these volumes, it persists our Redis data to this particular directory, which will be created under the controller. So we, just like we did here under DB, can you see these volumes? We have Postgres data, right? So we need to copy this Redis data to the volumes section of our Docker Compose file. All right, so we are done with that. So I guess our Docker Compose is good enough. It's fine at this point. Okay, one more thing. We need the configurations. Like I mentioned in the last class when we started working with it, when you are creating Postgres database, you need some data like the Postgres user, what do you want it to be called, the Postgres password, and all that. So we are going to populate that to our DB, to our env file. So I will copy and paste here. At number one is a Postgres user. What do we want the user to be? And I want it to be called Postgres. Or password is still Postgres. Of course, can use anything. Then the Postgres server is DB. Please note that DB is this one. If this was called something else, you would have just called that something else as well. I mean, if this was something like DB suite, this would have been DB suite as well. But I wanted to call just DB, so that's what we're going to do. I guess with this, we are done with the Docker Compose. Yeah, with this, we are done. This is good. Docker from port database. Yeah, it's good enough. Please, do you have any question on this before we proceed to the project directory? There's this Twitter directory.
No question from me.
No question from me for now.
Okay. Is there a question from anyone? Okay. So actually, no questions. Just view. It is message in the chat. Let me check. My attention says no question. So the next thing we are going to do is to go to our project directory, which is Twitter. And the very first thing I'm going to do is create a Docker file for that. So I need to touch Twitter slash Docker file. Okay, so we now have a Docker file there. Then I'll need the requirements for text file. Alright, so requirements.txt files are the file where you store the dependencies you'll be using in the project. The dependencies and the exact version. So that's what we do with requirements.txt. The very first thing we are going to populate now is that Docker file. I will simply reuse the configuration we used in the last class and make a few modifications to it. Then when I'm done with that, I will then list the dependencies we're using for this project within this particular text file. So let me go to our format class project. We'll copy and paste. Okay. So from line 1, we are using an Ubuntu system with a Python version of 3.10.1, and we set the Python to fat to Python like bytecode to 1. Then at line 7, we are updating the packages. Then at line 10 we are setting the working directory, and I want to change that from projects to Twitter. Then at line 13 we are going to copy the requirements. This you can see copy /requirements.txt. Don't forget, a few minutes ago I explained it that when you see / it means copy that thing from the current directory. And this current directory, that's the directory where the Docker file is. We are looking for a requirements.txt file, and it is this one. So this command updating says copy this particular file into this Docker container folder of Twitter. Then paste the requirements.txt file there. Then at line 16, we are to run that command, that's pip install -r requirements.txt. Don't forget that if you want to install a package with pip, you send the command pip install package name. All right, but if you're installing a package from this requirements.txt file, you use pip install -r, and not just requirements.txt, like any kind of file, right? You put in the name of the file. So people go to the file and then install all the dependencies that are available in that particular file. So that's what we are doing at line 16. Then at line 19, we want to copy everything within this. You can see copy code base. Then copy dot means that everything within this directory, and we want to copy it to this particular folder, project folder. But in this case, we are not using project folder. Our project folder is actually called Twitter. So we want to copy everything within this directory to this Twitter folder. Then at line 22, we are creating a user for that particular container, and the user is called KodeCamp. Then we now set that user at line 25. We give this user permissions to our project directory, which in this case is Twitter. Then we now set our user. So that is that for Dockerfile. That's it. Let me check for. Let me go through it in case there are errors. Right, it looks fine. Looks okay. So now the next thing is to get the dependencies that I'll be using for this project. All right, so I'll copy the dependencies that we need to this requirements txt file. So to do that, I will perform a simple copy and paste. Yeah. Okay. Right. I'll remove some of these things. Okay. The first group is server, and for the server, we'll be using Fast API, and we'll be using this exact version. That's version 0.74.1. Then we'll be using Ginger. It's a templating system. We actually want to use it to write HTML emails. So that's why that's there. Then the second set of dependencies is for code formatting. I will make use of like 8, which is useful for it goes through it's a static profiler. It goes through your code. When you run it, it goes through your code and then looks for issues like common formatting issues, like common bugs like that. Right? It identifies them for you so that you can go through it and fix them up. Then we have Black. Black is an auto formatter that is easy to automatically reformat your code. So no matter how you write code, already you want it to be clean, and you simply run the Black command, and the code will be reformatted. We'll be using that a lot, so you see how it works there. Then the next set of dependencies will be related to databases, and the first one is databases. This one is really important. So then we'll make use of H. H is a migration tool. We use it for database migrations. Okay, we simply use it for database migrations. Like, let's say you want to create a table, you want to modify your table, something that we did manually in the last class, like add a field to a table, maybe drop a table, things like that. So instead of running the SQL code manually, you will be like using AH for it because it's a whole lot simpler. Then don't forget I spoke about Redis a couple of minutes ago, and like I said, it's an in-memory database that you use to store key value pairs within your RAM. So there's a Python package that helps you interact with this database, and it is called Redis. You can read more about it if you go to the documentation. So that's what we'll be using to actually interact with that database, this Redis package. Now, finally, we have Tortoise ORM. This is the database layer that we'll be using to interact with the database. We saw an introduction to TotalSORM in the last class, and in this particular project, we'll be making making use of it a whole lot. So that's that for the database section. From line 14, these are the packages that we'll be using for unit tests. We'll be making use of PyTest and PyTest Essential, which will help us write async tests. And we'll use HTTPX. It's an async request library. We'll see how it works in subsequent classes. Then we have SGI lifespan. Then we also have async tests. These are libraries that we need for unit and integration tests. We'll see how to use them in subsequent classes. Then we also need a library. We also need a couple of libraries for security. We have parsley. We'll use this for password hashing and verifying hash. Then we have Python Tuesday. We're using this for JWT tokens. Then we also have PyJWT. I don't think this is really necessary since they basically give something, so I'll take that off. Now we have another library that's called Kode3. Kode3 is let's go to the documentation. So let me switch to my browser so that we can go to the documentation together. All right, so Kode3 is the AWS SDK. What you mean by SDK is the software development kit for Python. It helps you to basically interact with AWS services from within your code. All right, let's say we want to upload something to S3, like S3 bucket, a bucket where you use to store static files like images, things like videos and all of that. You can make use of S3. Then you need to send out with Amazon ECS, you can make use of S3. And it's basically an SDK, software development kit that helps you interact with AWS services. So since we'll be using, I think we'll use a couple of AWS services. That's why I included that particular library service. Then the next one we are going to make use of is NumPy. NumPy is a package. It's a library for numerical computing, and I usually prefer to use NumPy because it's a whole lot faster. Let's say if you're doing mathematical computations in your code, it's a whole lot faster than in pure Python. Because let us go to the NumPy repository. So NumPy, the fundamental package for scientific computing in Python. Let's go through. There's something I want to show you. So as you can see, NumPy is made up of 62% Python, 35% of the code is C, and 1.2% is C++. So the main mathematical logic, the main heavy lifting logic is handled with C, right? And C is a low-level language, like a highly performant low-level language, right? And it's far more performant than Python. It's a whole lot faster, uses less memory and all of that. So if you need to perform a couple of computations with your code and you need it to be like very, very fast. You want it to be more performance than doing it in normal Python. You can make use of that NumPy. So that's why I'm including that here. We'll be using it for computations, like if we want to like compute something, add something, maybe divide something at scale. All right, instead of using just pure Python for it, we can just use NumPy for it. Then at 31, we have libraries for social authentication. Yes, if we want users to like have the capability to like log into our app with maybe log in Google or log in with Facebook and all of that. That's what this Google Auth is used for. But thinking about it, we don't need this, so plain off. Then QR code scan, we're not going to scan any QR code, so I can simply print this out. With this, our requirements.txt file is ready. These are all the packages we're using. If we need something else, I'll simply edit this and rebuild the project again. So before we start building this, do we have any questions? Please, any question on this?
No question from me for now.
Okay. Okay. Does any other person have a question? Any questions so far? All right, I believe there is no. Just that, okay. There's many packages to know. There's from Ensure. Yeah. There are a lot of things. There are a lot of packages to know. And you know, the beautiful thing about an open source language like Python is that many people are afraid to like build things that make your life easier as a developer. Just imagine having to, okay, for example, I need autocode formatting because I don't really have the time to like, write the code and then go back and format it properly. All right, I need an auto formatter. It really makes sense for me to just build it from scratch because I need to use it on a single project. Right, so that's how this project like this comes, just like this comes, so that other people can just plug into your code and start making use of it. So that's that. In the absence of any question, we are going to build this project, and we are going to build this and start writing the code for the software. So we will build the Docker project with that's a Docker Compose project with Docker.compose. And please note, you need to have Docker and Docker Compose installed in your machine. And I think I saw a couple of questions in the group chat about maybe the Docker file not working because it's a Windows machine. Please, it will work as long as you have Docker and Docker Compose installed in the machine. This exact same setup will work. Just run the commands and it will definitely work. So we are going to build this, and it should take a couple of minutes. So I'll mute my mic and wait for it to finish building.
Wow, it's really taking a lot of time.
I think it's because there are many requirements.
Okay.
Right, so the project is done here. We are done building. Now, the next thing we are going to do is to like actually set up the code files. Alright, we are going to set up the code files and put the necessary folders and just set up the code shell. So I'm going to create a server server.py file which will house our app. So I will simply touch Twitter/server.py. Then I want to create another file which will handle our Hello, sorry, I was lost for a couple of seconds. So let's go back to our code.
Right, so we can still see the screen.
Yeah, I'm sharing that now. Sorry about that. Okay. I think I was lost at explaining the purpose of this config. Right, so we need some environmental variables to be available within the code. Right. So with the code that we'll be doing that will be housed at this config.py file. Then I'm going to create a models folder, and this models folder will house a database model. So I'll call this models. Okay. Oops, sorry, it's not supposed to be there. It should be within this Twitter project. So I will delete that and create an around within this Twitter project. Okay. Now the next thing we are going to do is to create a folder for our utility code. Our utility code. So I'm going to store this in another folder called library. I'll store that there. Nice. Now let me copy what we had in the last class. Database of I will copy this. So within this library, the first thing I'm going to do is to turn this to a package by including this init file at root. Then within the library, I want to create another folder that will handle everything related to database. Then it's not supposed to be database of file. It's a folder. Then within that folder, I'll create a file that is called database of file. And within that file, I'll paste this code. This is the exact same code we had in the database of pi. This thing, database of pi file of the last class. So that's the exact same thing. And this particular file handles the database connections. Right. To handle database connections. Then the next thing we are going to do is to get is to populate our the server file. That's the base file. So for that, I'll simply copy and paste what we had in the last class, then I'll explain that. All right, so let me start from this database first. Like I had explained in the last class, this is the file that we use to initialize database connections. All right, so the very first thing we need is to import register totals from totals.contrib.fast API. And this register totals is housed in another function that is called initDB. And we want this function to be responsible for all database associations. Right? So the register tutorial takes an app, like your main app. Then it takes the database URL. I'm going to edit this soon. Then it takes the modules. These are the database models you want to work with. Then it also asks you if you want the schemas to be generated automatically, or you want to generate them manually. For a simple project, well, you can choose to generate it automatically or generate it manually, but I love to handle um, all database migrations, creation of tables, and all that with Eric. So I'm going to set this to false. I don't want it to generate this automatically. It should be set to false. Then when the connection is successful, it will print DB connection was successful. Then if there's an error, it will print DB connection error. Now, there's another function at line 22 that's called create startup handler, and this function is responsible for calling this init DB function. That's that for this particular file. Later on, when we populate this config.py file, I will come back and edit this. Right? I don't want to hard code these values within my code. Like, I don't want to input my username, my password within the code, because it's pretty much dangerous. Right? If someone has access to my source code, the person can basically get access to my database. So these files will be stored in my .env. Okay, these configurations, the database user, database password, and all of that will be stored in the .env that will not be committed to GitHub. All right. Then we are simply going to read that env file within our config, then import those values from the config here. So for now, we'll leave that for now. Then we'll go back to it later when we've populated this config file. Now, the next thing we are going to look at is this server.py. This is like the base of the application. All right, it is within this that it is within this file that the application is instantiated, and everything related to the application is handled here. So it's just what we've been doing. We first import fast API, then we are using list from type and save it. That's not necessary because I don't need this endpoints. I don't need those endpoints. Then we have from database import create startup, and we currently don't have any file called database within the base directory. Instead, our database is stored within library database. All right, so we are going to change that import in a minute. So I'm converting that particular folder to a package. All right, so now we are going to change this to from this to this one. It will be from library dot database import create startup handler. Then we can safely take this off. Then we don't need any schemas for now, so I will just leave that up. All right, please, this create startup handler is basically this function. You are just importing this function, and we will execute this function at line 18 whenever we start the app. We are adding an event handler startup. So whenever the app starts up, we want to basically get a connection to the database. So that's what we're doing. After getting connection to the database, we simply return the app. And then at line 17, we instantiate the app and store it in this variable called app.app. So I guess that is it. That is it. That is it. Okay. Then we get to config, right? So within this config is where you define your environmental variables, right? The environmental variables you want to share, like code-wise, right? You define them here. So this is how it works. We take, for example, this. Yeah, so this module handles application configurations. So to actually get an instance of these environmental variables, we import config from starlet.config. All right. Though if you look at the requirements of txt file, we did not explicitly add starlet, right, to our requirements, but Fast API uses starlet as a dependency. So when you install Fast API, it installs starlet for you under the hood. So we are getting this config. We are getting this config file from starlet, and there's another thing that is called secrets. If you want to store like secret data, like things like maybe access tokens, all right, we make use of secrets. We will see how it works in a few minutes. So we are going to create our first configuration file, and I want to set a couple of things. All right. Then before we use config, we need to, this config is like a class that we instantiate. All right, so we instantiate this config and then pass in this .env, which is your environmental variable, and this .env is basically this particular environmental variable you created here. So this will read, this particular line will read all the variables that you had stored within this .env file. So that's what we're doing there. Then we are setting a testing variable. That's testing is equal to config testing. So what this particular line does is that it will go to this environmental variable, all right, this environmental variable, and then check if we have anything like testing. This is what I mean. Something like something like this. So this config will check that environmental variable. This environmental variable you loaded to it. It will check if there's anything like testing, right? And the value we get from it, what do we want it to be? Do you want it to be a string? Do you want it to be an int? Do you want it to be a bool? All right, we want it to be a boolean because we're using either true or false. Then if that particular environmental variable is not available, all right, it will default to false. So if we don't have this testing here, let's assume we don't have this testing here. This configuration will like create a testing configuration, like create a testing variable and then initialize it to false. But if we have that testing that we have it here, the testing within our app will be true. Then The next environmental variable I want to create is debug. So it will do basically the same thing, check if there is debug, and if there is debug there, it will set the debug variable to what you have there. But if it's not available, it will set it to false. Then we have another one, live. It will just do the same thing. So that is that. We are going to set something else. I want to define the, give me a minute, let me split my screen so it took long. Then I want to move this env file to the right. Very good. So the next thing I want to do is I want to define this Postgres user. For now, it is in this env file, but I want a situation in which I can access it from my code. So this is where this config comes in. I'll define the config for Postgres user, which is equal to config, just like this. But there will be differences. Right? There will be a couple of differences. The first difference is that we are going to change this testing. We are changing that testing to what we have in that env file, which is Postgres user. And I don't want it to pass to a bool. Like, we don't want to set the data type to a bool, because it is of course not a Boolean value. Instead, we want to set it to a special data structure that comes with Starlet and the secret. So we set that to secret, and we don't want to set any default. There's no default, let's take it like that. So with this, we can pick the value of Postgres user that we had set in our env, the env file. So if this Postgres user is Postgres, we can access that particular value from within our code. So I'm going to do the same thing for the rest of the values. We are doing the same thing for the rest of it. Okay, so we are going to repeat that for the rest of the Postgres configuration we have set. The second one is the first is Postgres user. We need Postgres password. So this will be Postgres password. Then we change this to Postgres password as well. Then we need Postgres server. Then we need the port. Then the last thing is the Postgres DB. Yeah. I guess with this we are done with the configurations for now. There's the environmental configurations for now. Okay. All right. So please, do you have any question on this? Like, I think I've made changes to this server file. We've made changes to, we've populated this config your Py file, then we've also done something here at the database of Py. Please, do you have any questions on this before we proceed? Is any questions so far?
Yes, quick question. This .env file, when we completed the config file with it, can we like erase or delete the .env file?
Okay, no, you cannot. You can only read from it. We are only reading from what we have there.
Okay.
Please, do you have any other question apart from that? Is any question? Okay, so I believe there is no question. Now, the next thing we are going to do is we are going to change this. All right, as you can see here at the database of Py file, I am putting my database URL here, which is not what it should be. It's far too dangerous. If I push this to an open repository, and this is a production database, it's very possible for someone to, because the person has the password, the person has all the credentials required to access it, the person can easily read my database. Right, so I don't want to do that. I don't want that to happen. So I am going to create, I'm going to import these variables that we have here, that we've created here. These environmental variables that we've read to this code. I'll import it to this particular file and then use it. So the first thing I'm going to do is to import Postgres user, Postgres password, Postgres server, Postgres port, and Postgres DB from config.py. So that'll be from config. So from config, import. I want to import Postgres user. Then I'll import Postgres password. Then I'll import Postgres server. Then I'm also going to import the port, Postgres port, and we'll also import Postgres DB. All right, then instead of using this, I am going to use do we want this? Okay. Instead of using this, I'm simply going to use an F string. Then the first thing we have here is the Postgres user. All right. So instead of hard coding the Postgres user here, we'll simply use this Postgres user that we have imported from config. So with that, we have we now have Postgres user there. Now the data after this column, this is the Postgres password, just the database password basically. So we had imported the database password as Postgres password, so we used that. Postgres password. Now, the next thing is the host, right? The server. So, and in our case, it is the Postgres server. So we change this DB to Postgres server. And the next thing is the port. That's the port. So instead of putting the port there, we'll simply use this Postgres port to refresh my environment. All right, finally is the Postgres DB. So we'll use that as well. Good. I think with this, we are good to go. All right, I can then remove this. Okay, so with that, we now have the DB URL all set. Now, the next thing we are going to do, I think we are almost done with this setup. We are almost done with the setup. So one more thing is left. I want to handle the database migrations using Arich, right? So I don't want the schemas to be generated automatically for me. I want to do that manually with Arich. Okay, so I'm going to copy the Arich configurations down there, and we will go through it together. Okay. So just above this initDB function, I'm going to paste this. Then we'll go through it together. Okay, hosts. This will be, instead of database hosts, it will be Postgres server. So press that, then instead of database ports, we're going to have Postgres ports. Instead of database user, we are going to have Postgres user. Instead of database password, Postgres. Then okay, so this is what is required to enable Arich. The tool we'll be using for the database migrations to access the database. Right, you can see these connections. This is basically a dictionary, right? And the dictionary has two items. First is connections, and connections takes another dictionary, and the default connection takes these particular values. The engine is tutorials.backend.async pg. That's the database engine we are using. Then it also needs to, since it is creating these models for us, it needs to have the details of, it really needs to have the information, the data it needs, the credential it needs to access the database, all right? So it needs the host, the database host, the database port, the user, the password, and the database name. So this is what we supply to it. Now, the models you want to create, what models do you want to create? They are stored in this models list. We have models, we've not created it yet. They will be stored here. And then we have h.models. These are the models that are generated automatically when you install h to the container. So that's that for this. The next thing we are going to do is to, I think, would be to, okay, let me pause for questions first before we go to create the models. Let me pause for questions. Then when we are done with that, we'll create the models. Is there any question on this before we proceed?
Okay, no question. There's a lot here, but I can make research on just to understand. But basically, there's no question.
Okay. That's it. MJ, any question?
No question for now. Still moving.
All right. So the next thing we should do, I wanted to first populate these models, like the database models we work with. This is basically what we did in the last class, where let me refer to the code again, where we created a student model, like the student table. All right. So that's what will be in this models folder. Basically, the models we want to work with. But before I get to that, I want to ensure that what we have is correct. Right? Basically, what we have is correct, so that if there are errors, we can then fix it before this. So I'll create a new endpoint, set up the kit, and I want it to simply return hello. So we are creating an endpoint, a very simple endpoint that returns hello world. It doesn't really do much. I want to use this and test that we have a working setup, that there are no errors, so that we can quickly fix if there are any errors and then proceed from there. Now, I will start this container with docker compose up. That's the command used to start containers. Docker compose up. Let's check if we have any errors, so that we can fix that. It's still starting, so we have an error. Okay, it was expected. Set runtime warning. Models as no models. Okay. So here is the issue. As you can see, we have that DP connection is successful. All right, but there is an error at user local lib Python 3.10 packages tortoise in it, returns a runtime warning that models has no models. So if we go to the database of Pi, you will see at this point we declare the models list, right? Which lists the module that has the models we're using for this particular project, and we set that module to models. Ignore the second one, enriched of models. It comes automatically when you create when you install Arch. So this is the models. But if we go to this model, if we go to this model, we actually have no model there. All right, so that is why we're having this particular. That's why we're having this particular error. If we create a model, then this should be resolved. But let me see if I'll be able to start this server regardless of that. Okay, we should still be able to reach it. Let me share my browser. So as you can see, we have what we expected to have as detailed hello world. So that means our code is working, everything is working as expected. So we are going back to the project code. At this point, we can safely shut down the server because we are sure that everything is working. Now, the next thing we are going to do is to create the models. Right, that's what we are going to do. We are going to create the database models we'll be using. So before I do that, let me commit this code to GitHub and push everything down there. All right, so I've pushed the existing code to Git. Okay, so the next place we are going to work on is these models. All right, we want to build a Twitter-like kind of we want to build a Twitter-like kind of API. So the first thing we need is, of course, users should be able to create accounts, right? So that means we need tables for users. So first, I will create a new file. This will store the models that will be related to the user. Things like maybe user accounts, things like maybe images and all of that. So we'll create those models within this particular module. Now I'm going to create another module, and this module will be responsible for contents. Contents.py, and models like tweets, tweets, replies, and all of that will be stored in this particular module. Then I'm going to create another file called this.py, which will store the shared logic that I'll be using across each of those modules. So I am going to do a little copy and paste here. Second, I will get this. Okay. So let me go through this. We have at number one, we are importing fields from Tortoise, and we are also making use of the models class from Tortoise models. And I guess we did this in the last class. The fields are like the table columns, all right? The table columns. Then, while this model is a model you inherit, let's say if you want to like create a database model, right? You need to inherit from that base model, right? So that's what helps Tortoise to like know that okay, this particular class you are creating here should be converted to a database table. So that's it. The first class we are creating is a datetime mixin, a datetime model mixin. The thing is, we want every single table we create to have a created at field, all right, to be like fields.datetime field out now is equal to true. This means that every time that particular record is created, we want that time, the time that it is created, to be appended to this field. Then we also want another field, which is updated as, which should record the time that that particular field is updated. Then why I'm abstracting this away to a separate mixing is because I don't want to like repeat created that, updated that for every single model that I'm creating. So it's much better to create a separate class and then input these values, define these values there. Then for each model I'm creating, I'll just inherit from these classes. Don't forget class inheritance. That's what we did in a couple of classes ago. So that's exactly what I want to do here. Now, is also the same thing I'm doing here at line 12. We have abstract-based model, which also inherits from model. I want each field that I'm working with to have I want it to have an ID, which will be a primary key. All right. So instead of like repeating this for each and every model that I'll be working on, it's much easier and much cleaner to define it here and then inherit it. Like get all the models that I'll be creating to inherit it. So now, instead of using int field, let us use the UUID field we used in the last class. So we're going to use UUID field. So with that, we are done with the base models. So please, do you have any question on this before we get to content and users? Okay, before we get to users.
Okay. The abstract based model, is there a reason you separated it from the datetime class? Couldn't there be, is there a specific reason? Maybe why didn't you make everything to be one class here, since everything is under the base? So
you are right, seriously, you are right. You could do it that way. All right, you could do it that way. There's really no reason. It could have been that way. I think let us do that instead.
okay.
Yeah, let us do that instead. Okay. Then instead of using this separate, we will just copy and paste. Let's do this instead. Then class meta abstract is equal to true. Let me go to the docs and let us see what that abstract means. So let's share screen to Google Chrome. Let's go to the photos box. Okay. Now let's look for meta. Let's search for that. Abstract. I see it comes anything. Okay. So meta, the meta class is used to configure metadata for model. Okay, is a usage. Then abstract is equal to false, set to true to indicate this is an abstract class. Okay. This is an abstract class. Okay. Let's switch back. Okay, so why we need you may be wondering why we need this class meta abstract is equal to true. We don't want Tortoise ORM to create a table for this particular okay, of course we are going to delete this, we don't need this. We need it here instead. Let's delete this off. Let's call this base model instead. Okay, so what's happening here is that, you know, whenever you inherit this model class, you are telling Tortoise ORM that you want to create a table, right, for this particular model. But in this case, we don't want to create any table that is called base model. Like, we don't want any table to be created for this. You know, we are just creating this so that we can in subsequent models we are creating, we can inherit from this model. That we can get the ID, the created at, and the updated at field, like inherit these features from this model, all right? So that's why we add this class meta abstract is equal to true. We use this to tell Fast API that, hey, this is an abstract class, all right? We don't want you to create any table for this particular class. Okay, please, do you have any question on that before we start working on the other models?
No question.
No question from me. You can go ahead.
Okay. The next thing we are going to do is we are going to import that base model from that. So from models dot base, we want to import base model. Then we want to create a table for users, and this particular table will inherit from the base model. Then I will comment on this table, user table. So what happens here is that give me a minute, let me split my screen. So what is happening here is that since this particular model, this user model is inheriting from base model, all right, it will also inherit this model. Then it will inherit the ID, created at, and updated at field. So that way, this user will have an ID, will have a quick data and updated that without explicitly creating them here. So all I need is I need a user to have a username, and the username will be equal to fields.char field. So we are going to import fields from tortoise, import fields. So I want the username to be a character field. So use fields.char field. Then this char field needs to have a max length. So specify the max length to be equal to 50. The user shouldn't have a username that is more than 15 then should it be compulsory? Nope. I want to set no to true. What this means is that when we are creating a table, if the username is not supplied, all right, I don't want to have an error. So let that null be equal to true. Then what else do we need? Give me a minute. Okay, we also need the email. Then, yeah, I'll need the email as well. The email should be the same thing. Email should be the same thing, but I want the max length for email to be 100. Then we should have a first name and a last name. Yeah. We should have a first name and last name. Then we should have a last login. When did this user last logged in? So that would be a datetime field. Fields dot datetime field. Then I want it to be nullable, meaning it can be null. What else? What else? We need to store the hashed password. Don't forget, you're not supposed to store any plain text password in your database. So we are storing only the hash. And then I want the hashed record to take a maximum of 1,000 characters. So which other thing do you think we should store?
Maybe phone number.
Apart from this information. So the phone number.
Date of birth.
Okay.
Yeah, maybe date of birth too.
Okay. So let's say phone. Then date of birth. I want it to be childhood as well. Okay, I don't want to store the full date of birth already as a record. Let's use day of birth, the month of birth, and year of birth, so that it's easier for us to manipulate later.
Okay. I was even thinking whether we add some kind of data validation, like the email now. Maybe we use email str, the date of birth, since they are all numbers. Maybe, for example, the year of birth, we could add some kind
Yeah.
of validation that makes sure if it is four numbers or four digits, something like that. So I
Yes,
don't know if
this is the database. All right. We don't. I usually don't like doing the validation here. We do the validation at the schemas. When the user is sending the data, the pedantic model, it's better to run the validations there.
okay,
Do you understand?
yes.
Okay,
So
okay.
when the user is sending the data to that particular endpoint, we run the validation at that point, not on the database. The advantage of that is that, if the validation fails, let's say in this case we have that the max field is 10 here. If the user enters something that is more than 10 and you allow it to pass down to this point, you have a 500 error. That means your server will fail. You have an internal server error. So it's better to run that validation um, at the pedantic level. All right. So at that point, the data will be rejected and the error will be returned to the user instead of the server failing internally. Let me change this to 20. The 10 is too small. Let me change this to 20. Good. Which other data would we need? Let me check.
What of maybe
Yes.
user uploading like maybe file, like since we talked about file, maybe profile picture or something.
Yes, we'll create a separate table for that. Email verified. We don't want users to, you don't want someone to like spam our API, or maybe like enter a fake email and all that. So we want a situation in which the user must verify his email before he can log in, things like that. So we need to store an email verified field here, which by default is false. So when the user wants to log in, we check if this email is verified. If it's not verified, we then reject the login. So this will prevent spurious kind of logins. So that's that. Time is up actually. This class is supposed to be today and tomorrow for. Okay, today was meant for the project setup, and tomorrow is registration, login, and all. So we are done with the project setup. From next class, we'll start working on the registration. We'll complete these models. I will complete the models. It's part of registration. So we'll complete a model for this user. We need a model for tweets. We need a model for files so that whichever file the user uploads will then be tracked here. And I guess that's all the models we'll be using. So please, do you have any questions so far?
Okay,
Any
I was
questions so
saying, like, what if you want to account for maybe user uploading a file, like a picture?
You said you will create another
Yes. It will
file
not
for
be.
that.
Yeah, it will not be stored on this. It will not be stored on this particular table. This is the user's table. Right? There's what we call
Okay.
one-to-many relationship. Here, we'll create a separate table that is linked to this table. So a user can then upload his or her files to that one.
Okay.
Right? Then we can then track the uploads. Right? Since we know which user uploaded which, so we can do the tracking on that one.
Okay. So if this your code now, if you, since it's inside the Docker environment, if you, let's say, as you push it to GitHub now, do we need to like recreate, let's say, set up our Docker environment and install all the requirements again on our end?
No.
To
You know what you need to do? To actually run this code, what you need to do is install the kind of configuration. Right? And when you are done with that, you pull this code from the code. Then after pulling code, you run docker compose, docker dash compose, then then build. Right? You can see my screen, right?
Yes.
Yes.
Docker compose build. So this command will then go through this Docker compose or YML file to build all these services. Right? We have 3 services so far. We have Redis. There's an in-memory database. Then we have DB, our normal Postgres database, and we don't have Twitter, which is the core server. So it will then build everything. When the build is complete, you run the server with Docker compose up. So these are the only commands you need to use. Docker compose build. When it's done building, you type Docker compose up and it will start everything. So in the next class, I'll create a makefile. Let me do that now. So this makefile will contain all the list of commands we're using. Like if you want to start this server, build the server, and all of that, so the list of commands will be listed so that you can just copy and paste whatever you need to use. So that's it. Is there any question? Any other question?
No question for now. No question.
Yeah, no question from me.
Okay. So that is it. That will be that for the class. Let me push this to GitHub so that you can access it from me.
All right. Sir.
All right. So I've pushed. You can then pull from the class repository and go through it from there. So thanks a lot for showing up. Really appreciate it. And,
Thank you very much, sir. Thank you, sir.
All right. So thank you, sir.
All right.